upstream and downstream word problems, headwind and tailwind word problems. Do unto those downstream as you would have those upstream do unto you. Wendell Berry. Upstream. Moving in the opposite direction from that in which a stream or river flows. The rate of a boat upstream is equal to the rate of the boat in still water plus the rate of the current. Downstream. Moving in the direction in which a stream or river flows. The rate of a boat downstream is equal to the rate of the boat in still water plus the rate of the current or stream. Tailwind. A wind coming from directly behind on an aircraft blows in the direction of travel. Ground speed is equal to air speed plus wind speed. Headwind. A wind opposed to the course of an aircraft blows against the direction of travel. Ground speed equals air speed minus wind speed. The speed of a boat in still water is 15 miles per hour. If the boat travels 8 miles downstream in the same time it takes to travel 4 miles upstream, what is the speed of the current? Speed of the boat in still water is equal to 15 miles per hour. Speed of the current is x miles per hour. Speed of the boat upstream is equal to the speed of the boat in still water minus the speed of the current, which is 15 minus x. Speed of the boat downstream is equal to the speed of the boat in still water plus the speed of the current, which equals 15 plus x. Construct the dirt tables. Distance traveled downstream is equal to 8 miles. Distance traveled upstream is equal to 4 miles. Utilizing the dirt formula, distance equals rate times time, or time is equal to distance over rate. The time upstream is 4 divided by the quantity 15 minus x hours. And the time downstream is 8 divided by the quantity 15 plus x hours. Time traveled downstream is equal to time traveled upstream. This fact leads to the equation 4 over the quantity 15 minus x equals 8 over the quantity 15 plus x on the domain open interval 0, 15. The GCF of the numerators is 4. To simplify the equation, divide both sides of the equation by 4. 1 over 15 minus x equals 2 over 15 plus x. Two equal fractions make a proportion. Use the cross product property of a proportion. 15 plus x equals 2 times the quantity 15 minus x. Eliminating parentheses and applying the distributive property of multiplication over addition. 15 plus x equals 30 minus 2x. This is a linear equation. Separate the variable by adding 2x and negative 15 on both sides of the equation. 3x equals 15. Divide both sides of the equation by 3. X equals 5, which belongs to the domain open interval 0, 15. The question asks us for the speed of the current. Thus, the answer is the speed of the current is 5 miles per hour. Adrian can row downstream 20 kilometers in 2 hours and upstream 4 kilometers in 2 hours. Find his speed rowing in still water and the speed of the current. Construct the dirt tables for downstream and upstream. He rows downstream 20 kilometers in 2 hours and upstream 4 kilometers in 2 hours. Utilizing dirt such that rate is equal to distance divided by time, Adrian's downstream rate is 10 kilometers per hour and his upstream rate is 2 kilometers per hour. We would like to find his speed rowing in still water along with the speed of the current. So let's let the speed of rowing in still water be equal to x kilometers per hour and the speed of current be equal to y kilometers per hour. Speed of the boat downstream is equal to 10 kilometers per hour, which is also equal to x plus y kilometers per hour, the sum of the speed rowing in still water and the speed of the current. This fact leads to the equation x plus y equals 10. Speed of the boat upstream is equal to 2 kilometers per hour, but is also equal to x minus y kilometers per hour, the difference between the speed in still water and the speed of the current. This fact leads to the equation x minus y equals 2. On the domain, x belongs to open interval 0, infinity, y belongs to open interval 0, infinity, and x is greater than y. This is a linear system of equations with two variables. We can solve it using the elimination method, adding the two equations. We obtain 2x equals 12, dividing both sides of the equation by 2, x equals 6, which belongs to open interval 0, infinity. Substitute x back into the first equation and find y. 6 plus y equals 10, y equals 4, which belongs to open interval 0, infinity, and x is greater than y, as stated in our domain. Thus, since we want to find his speed rowing in still water and the speed of the current, plugging in our values, we obtain that his speed rowing in still water is 6 kilometers per hour, and the speed of the current is 4 kilometers per hour. Sabrina's boat moves 30 kilometers upstream and 44 kilometers downstream in 10 hours. In 13 hours, it can go 40 kilometers upstream and 55 kilometers downstream. Determine the speed of the stream and that of the boat in still water. Let the speed of the boat equals x, such that x is greater than 0, and the speed of the stream equal y, such that y is greater or equal than 0, and x is greater than y. Y is greater or equal than 0 because the stream can be unmoving, or 0 velocity, and the speed of the boat must be greater than the speed of the stream because otherwise the boat will make no progress when it goes upstream. Constructing dirt tables. The speed upstream equals the difference between the boat's speed and the stream speed, which is equal to x minus y. The speed downstream is equal to the sum between the boat's speed and the stream speed, x plus y. She goes 30 kilometers upstream and 44 kilometers downstream in 10 hours. Applying dirt, distance equals rate times time, such that we can find time is equal to the ratio of distance over rate. We obtain an upstream time of 30 divided by the quantity x minus y, and a downstream time of 44 divided by the quantity x plus y hours. The boat moves 30 kilometers upstream and 44 kilometers downstream in 10 hours. Thus, the sum of the upstream time and the downstream time is equal to 10 hours. This fact leads to the equation 30 over the quantity x minus y plus 44 over the quantity x plus y equals 10. We would also like to make the dirt chart for the trip that takes 13 hours. The speed upstream is x minus y, and the speed downstream is x plus y. Applying the dirt formula similarly to before, we obtain a time of 40 divided by the quantity x minus y hours for the upstream, and 55 divided by the quantity x plus y hours for the downstream. In 13 hours, she goes 40 kilometers upstream and 55 kilometers downstream. Thus, the sum of the time upstream and time downstream is 13. This fact leads to the equation 40 divided by the quantity x minus y plus 55 divided by the quantity x plus y equals 13. This is a system of equations with two variables. We will use u substitution to solve it. Let 1 over x minus y equals u, and 1 over x plus y equals v. The given system is thus equivalent to the system 30u plus 44v equals 10, and 40u plus 55v equals 13. We use the elimination method to solve this system, eliminating the variable u. The LCM of the coefficients 30 and 40 is 120, so we multiply the first equation by 4 and the second equation by -3. We obtain 120u plus 176v equals 40, and negative 120u minus 165v equals -39. Adding these two equations, canceling out our u's, we get 11v equals 1, or v equals 1 over 11. Substituting v back in the first equation, 30u plus 40 times 1 over 11 equals 10. 30u plus 4 equals 10. 30u equals 6. Divide both sides by 30. U equals 1 over 5. Substituting back u and v into the u substitution equations, we get the following set. 1 over x plus y equals 1 over 11, and 1 over x minus y equals 1 over 5. Therefore, x plus y equals 11 and x minus y equals 5. Adding the two equations and eliminating the variable y is equivalent to 2x equals 16, x equals 8. Substituting x equals 8 into the equation x plus y equals 11 and get y equals 3. The request of the question was to determine the speed of the stream and that of the boat in still water. And the answer is the speed of the stream is 3 kilometers per hour and the speed of the boat in still water is 8 kilometers per hour. Rachel is on a boat that travels 6 miles per hour upstream and 10 miles per hour downstream. She was on the boat 5 hours but cannot remember when the boat went halfway and turned around. Find the time it took the boat to go upstream and how far she traveled upstream. Construct the dirt tables. She travels 6 miles per hour upstream and 10 miles per hour downstream. She was on the boat for a total of 5 hours. Let x be the number of hours the boat went upstream, such that x is greater than 0. She traveled for 5 hours. Thus, she went downstream 5 minus x hours. X is less than 5. Applying the dirt formula, we can obtain distances of 6x for her upstream travel and 10 times the quantity 5 minus x for her downstream distance traveled. The distance traveled upstream is equal to the distance traveled downstream. This fact leads to the equation 6x equals 10 times the quantity 5 minus x on the domain open interval 0, 5. Eliminating parentheses by applying the distributive property of multiplication over addition. 6x equals 50 minus 10x. This is a linear equation with one variable. To separate the variable, we will add 10x on both sides of the equation. 16x equals 50. Dividing both sides of this equation by 16. X is equal to 50 over 16. Reducing the fraction by the GCF of the numerator and denominator to 25 over 8, which is 3 1/8. X equals 3 1/8. 1/8 of an hour equals 1 over 8 times 60 minutes, or 15 over 2 minutes, which is 7.5 minutes, or 7 minutes and 30 seconds. The question requests us to find the time it took the boat to go upstream. So, that would be 3 hours, 7 minutes, and 30 seconds. The time it took the boat to go upstream. And how far she traveled upstream. Plugging in that value into the distance, we obtain 18.75 miles. Rachel traveled 18.75 miles upstream. Answer: the boat took 3 hours, 7 minutes, and 30 seconds to go upstream, and in doing so, traveled 18.75 miles. Marius flew his plane from Bucharest to Budapest. On the way there, he flew with a tailwind 1,000 miles in 2 hours. Flying directly against the same wind, he flew 2.5 hours for the return trip. Find the speed of the plane and the speed of the wind. Construct the dirt tables. He flies with a tailwind 1,000 miles in 2 hours. Applying the dirt formula, rate is equal to the ratio of distance to time. We obtain a rate for with the wind of 500 miles per hour. He flies for 2.5 hours for the return trip. Same distance. The rate is 1,000 divided by 2.5. Amplify this fraction by 2 to eliminate decimals. 2,000 divided by 5, which equals 400 miles per hour. Let the speed of the plane in still air equal x miles per hour, such that x is greater than 0, and the speed of the wind equal y miles per hour. Y is greater than 0, x is greater than y. Ground speed of the plane with a tailwind is equal to x plus y miles per hour, and ground speed of the plane with a headwind is x minus y miles per hour. Ground speed of the plane with a tailwind is 500 miles per hour. Ground speed of the plane with a headwind is 400 miles per hour. These facts lead to the equations x plus y equals 500, x minus y equals 400. This is a linear system of equations with two variables. Eliminate the variable y, add the two equations, canceling out the y, obtaining 2x equals 900, divide both sides by 2, x equals 450. Substitute 450 in the first equation and get y equals 50. Answer: the speed of the plane is 450 miles per hour. The speed of the wind is 50 miles per hour. A hot air balloon travels 40 miles against the wind in the same amount of time that it travels 200 miles with the wind. If the speed of the wind is 20 miles per hour, how fast does the hot balloon travel against the wind? Construct the dirt tables for against and with the wind. The speed of the wind is 20 miles per hour. The speed of the plane in still air is equal to x miles per hour, such that x is greater than 0. Speed against the wind is equal to the difference between the plane's speed in still air and wind speed, or x minus 20 kilometers per hour. Speed of the plane in still air is equal to x. Speed with the wind is equal to the sum between the plane's speed in still air and the wind speed, or x plus 20. A hot air balloon traveled 40 miles against the wind, so we fill that in, and 200 miles with the wind. Applying the dirt formula, such that time is equal to the ratio of distance to rate, we obtain 40 divided by the quantity x minus 20 hours for against the wind, and 200 divided by the quantity x plus 20 hours for with the wind. In the same amount of time leads to the equation 40 divided by the quantity x minus 20 equals 200 divided by the quantity x plus 20 on the domain open interval 20 infinity. Dividing both sides of the equation by the GCF of 40 of the numerators, we obtain 1 divided by the quantity x minus 20 equals 5 divided by the quantity x plus 20. Two equal fractions make a proportion. Applying the cross product property of a proportion, we get 5 times the quantity x minus 20 equals x plus 20. Eliminating parentheses and applying the distributive property of multiplication over addition, 5x minus 100 equals x plus 20. This is a linear equation with one variable. Separate the variable by adding 100 and negative x on both sides of the equation. 4x equals 120. Dividing both sides of the equation by 4, x equals 30. How fast does the hot air balloon travel against the wind? The hot air balloon moves at a rate of x minus 20 miles per hour, or 30 minus 20 miles per hour, or 10 miles per hour against the wind. Thus, the hot air balloon travels at a speed of 10 miles per hour against the wind. Marius and Omer are flying cross-country, but starting on opposite sides. Marius experiences a headwind of 15 knots the first 2 hours of the flight. After the first 2 hours, Marius experienced a tailwind of 22 knots for the remaining of the flight. The opposite is true for Omer, who experiences a tailwind of 15 knots for the first 2 hours, and then a headwind for the rest of the flight. In still air, both of their planes have a max speed of 500 knots. What must the flight distance be for the two aircraft to land at the same time? Marius experiences a headwind of 15 knots the first 2 hours of the flight, and a tailwind of 22 for the remaining. Both their planes have a max speed of 500 knots, thus we can construct dirt tables. The rate of the plane in still air is 500 knots. The rate of the plane with headwind is equal to the difference between the rate of the plane in still air and the rate of the wind. 500 minus 15, 485. And the time is 2 hours. The rate of the plane in still air is 500 knots again. The rate of the plane with a tailwind is equal to the sum of the rate of the plane in still air and the rate of the wind. 500 plus 22, 522 knots. Let x be the number of hours Marius's plane flew with a tailwind. Similarly, we can find Omer's rates with a tailwind and headwind respectively. The tailwind rate for Omer is 500 plus 15, 515. Because Marius and Omer flew in opposite directions, the number of hours Marius flew with a headwind is the same as the number of hours Omer flew with a tailwind. 2 hours. The rate of the plane in still air is 500 knots, so the rate of the plane with a headwind is equal to the difference of the rate of the plane in still air and the rate of the wind. 500 minus 22, or 478 knots. The number of hours Marius flew with a tailwind is equal to the number of hours Omer flew with a headwind, or x hours. Applying the dirt formula, we calculate our distances. Marius's tailwind is 522x nautical miles. Marius's headwind distance is 970. Omer's tailwind distance is 1030. And his headwind distance is 478x. The total distance flown by Marius is equal to the total distance flown by Omer. And this fact leads to the equation 522x plus 970 equals 1030 plus 478x. This is a linear equation. Separate the variable by adding negative 970 and negative 478 on both sides of the equation. This is equivalent to 522x minus 478x equals 1030 minus 970. Performing calculations, that would be equivalent to 44x equals 60. Dividing both sides of the equation by 44, x equals 60 over 44. Reduce the fraction by the GCF 4, 15 over 11. What must the flight distance be for the two aircraft to land at the same time? The flight distance is equal to 522x plus 970. 522 times 15 over 11 plus 970 is equal to 1850 over 11, which simplifies to 1681 and 9/11 nautical miles. Thus, the answer is the flight distance for the two aircraft to land at the same time is 1681 and 9/11 nautical miles. The end.